In this video, we are going to learn how we can add two vectors. And the method we are using is a geometrical method. So there are many other methods to add two vectors, in which geometrical method is one important method and is quite easy also. But easier to this is a method which is all related to the resolution of the vectors. So when we resolve the vectors and then we add it, it is more easier. But this one is very important to understand how the addition of the vector works. So come on, let's get into it. So before we get into the addition of vectors in a very proper way, before that I just want to help you with how to find out why we need addition of vectors. So for that I am taking one example. I am taking one ball. It can be a football, can be any other ball. Alright? So now what we have to do, we should know that in a football ground, there are situations when two persons are hitting the ball at the same time. There can be situations like this. But this is one situation in which two persons is hitting the ball at the same moment. And the directions of the forces that they are applying are different. Suppose this direction is, this is the force F1, and you can see the direction by the arrow, and another force F2, this is in the other direction. Now there can be F1 is a force and F2 is another force. Might be equal, might not be equal, we don't know. What we all know that there are two forces and they are in these directions. So students, one very important thing is this ball will move from here to maybe somewhere. We know something about the direction of the movement of ball. If F2 is of higher magnitude, force F2 is of higher magnitude, the ball will move closer to this direction. It will move closer to this direction. F1 is more in magnitude. It will move closer to this direction. With this, I want to say that a very important thing here is the ball will move only in this vicinity, either here, either here, either here, but it will not go this direction, it will not go this direction. If two forces are exerted, the resultant force, the total force of these two forces, this force is F1, F2, it can be of other names also, but the resultant force, the total force, the addition of these two forces will be only within this range. The direction will be only within this range. It will not go beyond the smaller angle. This is the smaller angle that these forces are making. The larger angle is this. So it will not get into the larger angle. And since forces are vectors, that's why we can now understand how the addition of vector works. Here what we did, here we exerted two different forces on one object, and exerting two different forces means adding these two forces which are in different directions. Now think of the same forces F1 and the same force, another force F2, if applied in the same direction, the total force will simply be added, F1 plus F2, and we will get the resultant force. Simple addition. If this is 5 Newton and another one is 10 Newton, so total will be 10 plus 5 is 15 Newton. It's as simple as that. And if these forces are in opposite direction, F1, F2, just opposite direction, so the angle between these two forces is 180 degree. And when it is in same direction, the angle between these forces will be 0 degree. So if the angle between these forces is 180 degree, then we will subtract. Total force will be F1 minus F2 or F2 minus F1. Both way we can do, there is no problem at all. Finally, whatever the value will come will be the difference of these two forces. But when we are given with forces of different directions, then we need a rule for addition. And there are two rules. The one is triangle rule of addition and the second one is parallelogram rule of addition. And first we will discuss triangle rule of addition. One thing is very important here. Adding two vectors is possible only when both the vectors are of same physical quantity. It means we cannot add velocity and displacement. We can add displacement and displacement, velocity and velocity, force and force, but we cannot add displacement and force or something like that. So first we are going to discuss triangle law. In triangle law, there are two vectors. When they are added, the third vector comes and all these vectors makes a triangle. Here we can see there's a vector A, this vector, the vector in red color, another vector B, which is in blue, and when these vector gets added, we get a altogether new vector, which is vector C, and all these three vectors make a triangle, and this is why we call it triangle law of vector addition. Sometimes you have to deal with triangle law of vector addition, in which you have to draw these arrows and find out how you come to the addition of the vectors. So for that, what you have to keep in mind, you will be given with two vectors. So what you have to do, you have to add, when you have to add these two vectors, you have to find out, or you have to understand what is the tail of the vector and what is the head of the vector. So for vector A, the tail of the vector is here, the tail, and head of the vector is here. For vector B, tail of the vector is this portion and head of the vector is here. So in adding two vectors, we match the head and tail of the vectors. If we match head and tail of the vectors, we get the resultant vector. Students, vector addition is commutative. It means A plus B is equal to B plus A. Order is not important, and this is also not important when we draw the triangle. So let's see how we can draw A plus B and B plus A and we will get the same C. So here we simply see that A plus B is giving C. So from C is equal to A plus B. Now just rearrange the vectors. So here we actually used vector A first and then we put the vector B. Now we'll rearrange it. So please look at this. We are going to rearrange this. So now what we will do, we will actually put vector B first and then we will put vector A. So now we are putting vector B first. So vector B will be put first. And then we will be putting vector A. So this is vector A. And see, we are getting the same result. From the tail of B to the head of A, we get C, the same result. So the rearrangement actually worked. So let's go back and see. Are we getting the same result when we did A plus B? Here we did B plus A. Don't go with the letters, it's a mess inside because of the rearrangement, because of this software. But what we actually did, the figures we rearranged. The blue arrow we put it first and we consider it first, and then the red arrow is I'm putting it next. So let's see. Yeah, it's the same. It's the same. And hence we learnt vector addition is commutative. Now I also want you to see how the subtraction of vector works with the same figure. Students, suppose we have to find A minus B, vector A minus vector B. Then what are we doing in this? We are actually adding two vectors, which is one vector is A and another vector is minus B. It's just addition. But we will change the other vector into negative of the vector. So how do we do that in diagrams, in figures? You can see here, this is vector B and its direction is like this. The arrowhead is giving the direction. Now what will be vector minus B? It will be something like just opposite in direction, nothing else. And this we have to put actually. But how we can put this? Because we have to keep in mind we match the head of the first vector with the tail of the second vector. So we will actually reverse the vector. So this is vector minus B. So vector minus B is same in magnitude to vector B but opposite in direction. That's why it's minus B. And now the resultant vector can be found very easily. That is from the tail of the first vector to the head of the second vector, and which is A minus B or A plus minus B. And this way we can find the subtraction of two vectors. And now comes to parallelogram law. You know what is parallelogram? Parallelogram is a quadrilateral. It means it has four sides and the opposite sides are parallel to each other. So all the opposite sides are parallel, and then we get a parallelogram. So we have a B here, we can see B, so same B, a parallel B will have to be made here, and a parallel A has to be made here, and this is complete. We are done with the parallelogram law. But we will understand more mathematics involved in this. First thing first, here we will start from the beginning. Now we just know vector A and vector V, and we don't know vector C here now. For that, we are going to remove vector A plus B, that is vector C we are going to remove from here. And what we are given with, there is one angle theta between vector A and vector B. In triangle law, we joined the head of the first vector with the tail of the second vector here. But in parallelogram law, we will join the tails of both the vectors. We have joined the tails of both the vectors. And we find what is the angle between these two vectors, that is, suppose the angle is theta. And we draw a line further to A, like A will go further and it will be the same line. Another step is we are going to draw one perpendicular from the head of the B to the progress of A, and this is perpendicular, it means this is 90 degree, and this is theta. Parallelogram law says that the diagonal of this parallelogram is the resultant vector, what was also attested by the triangle law of addition in an altogether different way. So actually the same diagonal was used in triangle law, and that is the same is used in parallelogram law. But with the help of parallelogram law, we can find the exact magnitude and direction, the mathematical values of the addition of vectors. Using triangle law, we can only visualize it. We cannot get the magnitude. Few things important for the parallelogram law. One is that you add the tails of both the vectors. So here we are joining the tails of both vectors. Another thing, we are drawing the vector A. What is the purpose of doing this? After doing this and after putting a perpendicular from the top of vector B, that is this point, to the vector A, we are getting a right angled triangle ABC. Now, working on this right angled triangle, it is very easy to find the magnitude of the hypotenuse of this triangle, which is AC. So AC is the vector C, which is A plus B, and which is the resultant of the vector. It is very easy to work with right angled triangle. We can use trigonometry and we can simply get the value, the magnitude of AC or C, vector C. For that, what do we need? We know this distance, which is given the value of vector A, the mod of vector A. We know the angle, the theta, but we don't know what is BC, which is the perpendicular. So to find the perpendicular, we can simply use trigonometry, because B is given, theta is given. Now, what will be the perpendicular? It will be B sine theta. Every time perpendicular is sine theta, and if hypotenuse is given, so we just multiply sine theta to the hypotenuse to get the perpendicular, and we can also get the base, that is b cos theta, and we get the value of this distance. And now we have, for the triangle ABC, we have the base, which is AB, and AB is magnitude of A plus B cos theta. We will just add these two things here and this. So we have base, and we have the perpendicular, which is BC, and which is B sine theta. And to find AC, we can use the Pythagorean theorem, which is hypotenuse square is equal to the base square plus the perpendicular square, or hypotenuse is equal to under root of base square plus perpendicular square, which is square of AB plus square of BC. Students, we are actually finding the magnitude of AC, the magnitude of the resultant vector, or magnitude of the sum of the vector A and B. For that we are doing all these things. For that we are going to make a right angle triangle. How we can come to a right angle triangle? So for that we do certain things. And to get the magnitude of the vector, we are doing all these calculations. And finally we are here adding the base and the perpendicular to find the hypotenuse AC. And now let us calculate this. A plus B cos theta square will be A square plus B square cos square theta plus 2AB cos theta plus B sin theta square will be B square sin square theta. Alright, now here we have A square, we have B square and cos square theta, and here it is sin square theta. So B square will be common, and we can write sin square theta plus cos square theta and plus 2AB cos theta. And what we get is A square plus B square. Sin square theta plus cos square theta is 1. So we will just write B square, and then we will write 2AB cos theta. And this is the magnitude of vector C. So if two vectors are given, vector A and B, and the angle between these two vectors are given, what will be the addition of two vectors can easily be calculated using the formula, which is under root of A square plus B square plus 2AB and cos theta. Last thing to know is what is the direction of the new vector. What we got, the addition vector has a direction, and what is that direction? So here we can see the vector makes a new angle alpha. Now it is no more theta, which is the angle between vector A and vector B. A new angle is made by this vector, which is alpha, and what is this alpha? Alpha is actually giving the direction. If this is considered the x-axis of a Cartesian coordinate, then we can simply find the direction of the new vector, which is alpha degree from x-axis, or from any axis. We can take any axis here, but for the convenience we are taking the x-axis, and the new vector is in the direction of alpha degree from the x-axis. Now find out what is this alpha. What is the value of this alpha? To find out the value of alpha, it is very easy. We can find tan alpha or tan theta. What is then tan theta? That is perpendicular by base. So tan alpha will be the perpendicular, which is here b sine theta. And what is the base? A plus b cos theta. Or alpha is equal to tan inverse this value, and hence we found the value of alpha, which is the direction of the new vector. And with this we concluded the parallelogram law or the geometrical way of addition of two vectors. If there is any doubt, please do write in my comment box. We can discuss further. Thank you.